Hello everyone, welcome back to the last video of the lecture session. In this video, I will be giving a short introduction to the K-Nearest Neighbours algorithm, and it is the very preliminary and basic algorithm for you to fully exploit a dataset and get a predicted result. And let's get into it. So the KNN algorithm assumes that similar things exist in close proximity. This close proximity is not the physical distance, but rather the distance between the data points in multi-feature dimensions. So as I mentioned before, there are different distance metrics to calculate the distance. The most common one is called the Euclidean distance, where you're directly calculating the straight line distance between the two in the feature dimension. And here, for example, we have this data set with limited data points. And what if we want to find a class of a new data point, which is here, the green dot? We want to find a class of this green dot by comparing with its neighbors. So among all of these points, we will get the three closest neighbors. If these two are triangles, and this one is square, then we can predict that, okay, this green one will probably be a triangle as well. And what if we take 5 samples, and 3 will be squares and 2 will be triangles, then this green dot will probably be a square. But there are interesting cases where we take 4 samples where 2 are triangles and 2 are squares. In this case, the classes are even. What do we do in this case? How do we break the tie? Let's get into the detailed algorithm. The algorithm here is very long and dry. I hope I don't bore you, so I will provide an example with house pricing prediction. So for example, we are living in this greenhouse, and in this neighborhood we have other houses around us, and we decided to sell our house, but we don't know what price to put. So a method we can use is use KNN to compare the price in our neighborhood in order to get a price prediction for our house. Well, to simplify this example, the physical distance could be our distance calculation in this example. So in our data, the features will be real-world coordinates, for example, like a GPS. And when we say the nearest neighbors, it will actually mean the actual nearest neighbors in this neighborhood using physical distance. Okay, so let's now start with the algorithm, and I'll be using this example to explain the algorithm. First, we load the data. Of course, we will be finding all of the surrounding houses and their prices in our data set. And we initialize k to be our chosen number of neighbors. Okay, and we say, let's choose 3 for now. And for each example in the data, so each house is in a neighborhood, we calculate the distance between the query sample, which is our house, and the current sample from the data. So for each of these houses, I will be calculating the straight distance between them. And then we add the distance and the index of the example to an ordered collection. We sort the collection of distances and indices from smallest to largest, and we do that, we sort by the distances. So we look at the distance between our own house and the neighborhood houses. We sort these houses based on distance. For example, I would say this is the closest one, this will be the second closest one, this will be the third closest one, then 4, 5, 6. And then we pick the first k entries, the first 3 entries, as we specify k to be 3, from the sorted collection. Okay, then we will pick the first 3 closest houses in our neighborhood. It will be this one, and this one, the 3 red ones. and we get the labels of the selected K entries. The labels here is of course what we want to predict, which is the price. Okay, then we look at the price of these 3 houses. And finally, since this in this problem we are dealing with house price, which is a numeric number and it's continuous, so we will do regression by returning the mean of the 3 labels. So we're calculating the average price of these 3 houses, and let that be our house's price. I think in real world, when real estate agents propose a housing price for some house in sale, they will use the same method to compare the houses close in the neighborhood, and also compare the conditions of the house and select the similar houses condition. For example, the land area, year built, the long condition, structure of the house, building materials of the house, etc., and find the most similar ones, and then use their prices to come up with the prediction for the house's price for sale. And in classification problem, remember the case I introduced in the last slide. If we have labels equal in number, then we will take one more sample from a data set to comparison. For example, we have 2 versus 2, then we will take one more, and that will make a 3 versus 2 situation. Then we can take the mode among these labels and get a final prediction. Okay, so this will be the end of the lecture part of the session. And in the next video, which will be the tutorial, I will be using Google Colab to make a live demo on KNN algorithm using a real-world data set, which contains all other informations I mentioned as the features in the data set. Okay, thank you very much for watching all of these videos, and I hope you can enjoy the next demo, and see you there.